Jets! Welcome to Algebra 2. This is Apple Jen, and today we'll be covering 1.1 and 1.2 of the Holt McDougall's Algebra 2 textbook. 1.1 will be identifying and graphing linear equations, and 1.2 will be finding the slopes of these linear equations and identifying and finding their x and y intercepts. So let's go! So first of all, 1.1, when we are identifying and graphing linear equations, what we have to memorize and what we have to know is this formula right here, y equals mx plus b. Although math is all about understanding what is happening and using that to solve problems, this is one formula that you must memorize. And this might be a review from pre-algebra and algebra 1, but because algebra 2's chapter 1 is mostly review, we will be covering this again. And if you do not have this memorized yet, please do memorize this formula, as it will come up thousands of times in the future, and you will have a very hard time with math if this is not ingrained into your brain. And for this total charge equals variable charge plus fixed v, we will get back to this later. But using this equation, y equals mx plus b, first of all, mx represents the average rate of change, which we will get to in 1.2, and b is whatever amount you're adding or subtracting from this rate of change, and y is that value. So we'll try graphing some of these equations first. So let's say we have a word problem. So you have a job, a part-time job, where the flat fee, so what you get no matter how many hours you work, your initial fee, your wage, that is $5. So you get $5 no matter what because you signed up to do this job. And then you get $5 more each hour. So then we use this word problem to first find some points that we can graph to graph the linear equations. And this is a linear equation because we are adding the same amount, the same value every time we increase the amount by the same amount. For example, when we are going from 1 hour to 2 hour, the amount being added to your wage is $5. And then this is the same for your second hour to third hour. When you go from hour 2 to hour 3, you're being added $5 more to your wage. That is the same for 3 to 4, 4 to 5, and so on. So firstly, we'll find some points so that we can graph this linear equation. So because right now your one-time flat fee is 5, we know that if you work 0 hours, you will get $5, although this is in a scenario where you will work more than 0 hours. However, this is your flat fee, so we have the point 0, 5. And then let's say you work 1 hour, then you get 5 plus 5, which is, for 1 hour, you get $10. So 1, 10 would be your second point. And then let's say you worked 2 hours, then added to your flat fee of $5, you're getting $5 from your 1 hour plus another $5 from your second hour, which is 5 times 3, or 15. So your second point would be 2 hours for $15. And then you can keep going like this to find that for 3 hours, you would get 20 because 15 plus 5 is 20. And as you can see this linear progression here, 5 to 10 to 15 to 20. And then we can keep going with this. So 4, 25, 5, 30, 6, 35. And we'll stop here, but you can keep going on forever and ever. But let's say you only work 6 hours for now. But then, of course, because we're doing a linear equation and seeing how much you can earn by working a certain number of hours, this will be a linear equation that will go on infinitely. So we'll make this have arrows at the end. And so after you find some points like this, we're just going to graph the same line because there's one average rate of change for a linear progression because we are increasing the amount by a set number that it does not change. It's very constant. So after finding a few points, you can go ahead and put them in a table like this. So 0, 5, 1, 10, 2, 15, 3, 20, 4, 25, 5, 30, and 6, 35. Oh, 6, 35. So I'm going to try to graph this and see whether this is exactly the same as the points that we just put in. And yeah, and if you connect the dots, this is what your equation will look like. However, because we are not finding the wage that you will get until you work 6 hours, we're trying to find how much you can earn if you work 25 hours, 30 hours, and go on infinitely. So we're going to find an equation. So let me just delete all of these. So going back to the slideshow, how you find this equation based on a word problem is total charge, so your total wage, equals the variable charge, which is how much you earn per hour, plus your fixed fee, which is your flat value, your wage of $5 when you work 0 hours. So using this equation, we can find that for the word problem that I gave, the total charge, let's keep it as a variable now, y equals, what is the variable change? You get $5 per hour, so 5x, because the x will represent how many hours you work, and then plus a flat fee of $5. So you can find that the equation that we have here is y equals 5x plus 5. And as you can see, if I delete this right here, this is the same as the plots that we just pointed. It is on the same line. It just goes on infinitely, that's all. And you can just keep zooming out and you'll see all the infinite sets of hours and wages that you can get. So you can see how much you can earn for, say, working 140 hours. So 140 hours, that would be a lot of money. And then you can also see that if you work like 100 hours, you'll get $500. And that is how you graph a linear equation. You just find the points, graph them, and then find the corresponding linear equation. So that was 1.1, and then we'll go on to 1.2, which is finding the slopes of these linear equations and then identifying and finding the intercepts. So we'll use the same linear equation for this. So first of all, slope is the average rate of change, how much your graph goes up by each value. So here you can see that 0 to 5, 1 to 10. So from 0 to 1, it changed 1 unit, and then 5 to 10, it changed 5 units. So as you go on, let's say 0 to 1 to 1 to 2 to 2 to 3, every time you're adding 5. So here we know that our average rate of change will be 5. And then this right here is another formula that you must memorize, which is y2 minus y1 over x2 minus x1 will give you the slope. So what is y2 and what is y1? So these subscript numbers 2 and 1, they're nothing fancy. They're just for example, if you have 2 points, let's say I use 2 comma 15 and 3 comma 20, then your x1 value would be 2, and then your x2 value would be 3. And then these 2 and 3 came from the 2 comma 15 and 3 comma 20. These points, 2 comma 15 and 3 comma 20, you can switch them up. 2 could be x1 and 3 could be x2, 2 could be x2, and 3 could be x1. It really doesn't matter as long as you stay consistent. For example, if you use 2 as your x1 value, then you must use 15 for your y the same y value. So like if you use 3 as your x2 value, then 20 must also be your y2 value. So when we use 2, 15 and 3, 20 for this example, I'll use 2, 15 as my subscript 2 and 3, 20 as my subscript 1. So 15 minus y1, which is 20, over x2, which is 2 minus x1, 3. So 15 minus 20 is negative 5 over 2 minus 3, which is negative 1. The negatives cancel out. 5 over 1 equals 5. So as we know, our hourly increase in wage of 5 is the average rate of change, and we can confirm this just as we just did by using this formula. And next, how do we find our intercepts? So when we're finding intercepts, we will work with the linear equation right here, y equals 5x plus 5. Of course, if you have a graph, this would be easy. For example, the y-intercept, which means the value that is on the y-axis would be 0,5 here, because when x is 0, y is 5. So that would be your y-intercept right there. And then my x-intercept would be negative 1, 0. So when y is 0, x would be negative 1. That is the meaning of the x-intercept. So if you have a graph, it's very easy to find these points. However, we will work with the equation right here. So how do you find the intercepts? So as I just said, when y is 0, then x must equal something. That is the meaning of the x-intercept. When y is 0, what is the value of x? That is the x-intercept. And it's vice versa. When x equals 0, what is the y value? That is the y-intercept. So when x equals 0, what's y? So we will do that for the equation right here, y equals 5x plus 5. So we just input the values. We input the zeros in. So we'll put 0 for y to find the x-intercept first. So 0 equals 5x plus 5. So we have 0 equals 5x plus 5. We subtract 5 from both sides to get negative 5 equals 5x. Divide by 5 on both sides to get negative 1 equals x. So now we have negative 1 as x and 0 for y to get negative 1, 0 as our x-intercept. And we can check that with our graph here, negative 1, 0. We'll now do the same for our to find our y-intercept, which is the point right here. So it's 0, 5. So if we find the right value, we will get 0, 5. So let's input 0 for x. So y equals 5 times 0 plus 5. Because 5 times 0 is just 0, we just get y equals 5. So we have x as 0 and 5 for y to get 0, 5. And as we confirm, the y-intercept here is 0, 5. So that is how we find the intercepts, the slopes, and how to find and graph linear equations. And I hope that this video was very informative, and I will see you in Algebra 2 video number 2. And that is it for today's video. So thank you, and see you next time.